Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college, live lesson A-level maths, year 2, pure maths. Today's topic is sigma notation, carrying on from the last lesson. Just looking at a slightly different example. Last time it was a formula which led to an arithmetic sequence, and this time it's going to be sigma notation, but where the formula leads to a geometric sequence. If you're following through in the book, then it's chapter 3 and example 18. Let's begin. Bismillah ar-Rahman ar-Rahim. So today the question is work out, and remember in words this question would look quite long and it would be quite a few words, but the advantage of sigma notation is that we can write quite a long question in a very short way. So just take a look at how the question looks and ask yourself, what is the real question? Okay, so that's the question. And what's it really asking us to do? It's asking us to work out the sum of a sequence where the sequence has got 12 terms starting from the first term going up to the 12th term. To generate the numbers in the sequence, the formula is 5 times 3 to the power of k minus 1. The k starts off as 1 to get the first term, and it goes up to 12 to get the 12th term. So let's take a look at what the sequence is going to look like. Let's start with k is equal to 1. So I would do 5 times 3 to the power 1 to the power 1 minus 1. 1 minus 1 is going to be 0. So really the first term is going to be 5 times 3 to the power 0. But 3 to the power 0, anything to the power 0 is just 1. So it's 5 times 1. But then timesing by 1 doesn't make any difference to a number. So it's just 5. Okay, let's get the second term. K is equal to 2. So here the k bit is 2. 2 take away 1 is 1. 3 to the power 1. So it's 5 times 3 to the power 1. 3 to the power 1 is just 3. So 5 times 3 is 15. They're the first two terms. See if you can do the next one before I get there. So k is equal to 3 for the next one. See if you can work it out and type it into the chat window. That was very fast, inshallah. So here the k would be 3. So you did 3 take away 1 is 2. So you're thinking 3 to the power 2. 5 times 3 to the power 2. 3 squared is 9. So 5 times 3, what did you get? 45. Very good. So 5 times 3 to the power 2. And 3 to the power 2, 3 squared is 9. 5 times 9 is 45. Good. So now looking at the sequence, and we need to get to the 12th term, but the idea is you can see what the pattern is, see what kind of sequence it is just from the first 3 terms. So have a look, what kind of sequence is it? And once you know what kind of sequence is it, then what are the key parts that we're going to need to know to be able to put it into the formula, to any formula for that sequence. So hopefully you figured out it's a geometric sequence. And then when you're thinking of the formula for the geometric sequence, any formula, whether it's the nth term or whether it's the sum of a sequence or whether it's sum to infinity, what are the key things that we need to know that we can tell from just the first 3 numbers? You should have figured out very quickly 1 or 2 of them because it's staring at you right at the beginning. Good. So first thing is A is 5. Next thing straight away you should be working out either the difference, good, or what the multiplier is. So here, it's called the ratio, but it really means the multiplier. To get from one to another, 15 divided by 5 makes 3. So the multiplier is 3. Let's just check that with the next pair. 45 divided by 15 is 3. So well done. 3 is right. And then how many terms are there? We can say n is going to be 12. There's 12 terms. And then what kind of, which formula do we need? We're asked to work out, this is the sum symbol, so we need to work out the sum. So what's the formula for the sum of a geometric sequence when there's 12 terms or n terms? It doesn't start as n over 2 because that's an arithmetic sequence. So for the sum of a geometric sequence, how does it go? So a times, good, it's a fraction, so we've got a times, then there's two versions of the formula, but I prefer to go with this one. So 1 minus r to the power n. Do you know what's going to come next? Can't find my mouse now. There it is. Okay, 1 minus r to the power n on the top. Close the bracket. And then on the bottom, you should have figured it out by now. It's just 1 minus r. Okay, this is the sum formula. The formula that you had typed into the chat window was for the nth term. So 8 times r to the power n minus 1, that's for the nth term. That's for a particular term. If you want, we did the first 3 terms. If we want, now we know it's a geometric sequence. If we want the 50th term, then we would just use ar to the power n minus 1. Here the question is a sum question. We want to work out the sum. So the formula is normally a bit longer to work out the sum. So it's a times 1 minus r to the power n over 1 minus r. So that's enough time for you to figure out what to put into which part of the formula. So the a is 5, so that can go in here. Your n is 12, can go in here. Your r is 3, so that can go here, and it can go here. And you really just want to be able to type that straight into your calculator in one go. If you've got a scientific calculator, Casio, Classwiz, or something like that, then you should be able to just type it all into one entry. So just use the fraction key and just type that straight in and tell me what you get. So you'd use the fraction key to get a fraction, and then 5 bracket 1 minus 3 to the power 12 would go on the top, and then on the bottom 1 minus 3. 1 minus 3, you'll get a negative on the bottom, but you'll also get a negative on the top, so 2 negatives. You should end up with a positive answer. Let the calculator do the hard work and tell me what you get. Should be quite a big number. Okay, no answers just yet. Give you a few more seconds to type that in. Okay, and hopefully you're about to get, or you have got, 132860. Okay, well done for following that. Next lesson we'll do iterative sequences. Join me then. Assalamu alaikum wa rahmatullah wa barakatuh. Peace be with you and the blessings of God.